Hello and good morning, and welcome back to the second part of this OSPF authentication tutorial, where on the first video, which if you haven't watched it and you wanted to see how we got to where we're at right now, you could go back and watch the first video, which talked about the three different types of authentication. We talked about with OSPFv2. We talked about null authentication, which is no authentication. We talked about simple authentication, which is just basic password authentication. And then we talked about the next step, or the next evolution in OSPFv2 authentication, which would be MD5 hash authentication. And so that's where we're at right now. So this video is going to pick up where that video left off. I haven't actually changed any of the configurations, as you can see here. We're still debugging IP OSPF adjacency, and key 20, which was the last key that we configured, is currently being sent and received. So if I do a do show IP OSPF neighbor, you can see that my neighbor relationships are up. In fact, I think I overlooked or forgot to run last night the do show IP interfaced fast Ethernet, and we're on rack 1 here, 00. Show IP OSPF interface Ethernet 00, because what we wanted to take a look at was that cryptographic authentication is enabled, whereas before with simple authentication it did not say cryptographic authentication, it just said that simple authentication had been enabled. And you can see here the youngest key ID is key 20. And so we are currently at the phase now where we would want to go ahead and enhance not only the key functionality and features with a keychain, but we're going to want to use a next generation encryption. And if you take a look over here, just as a quick review, we had talked about MD5 and how, per Cisco, MD5 should be avoided. And what we should be using, the replacement that says SHA-256, and that is considered a next generation encryption. In fact, we could actually go all the way up to SHA-512. Now, the key thing to remember here is that in order to use the HMAC-SHA authentication, you're going to need to be running iOS 15.4.1 T1, 15.4 T1. So show version, and then let me include software. So as you can see here, we're currently running iOS 15.4.1T, and this is the first iOS where this functionality with OSPF version 2 has been enabled. If you wanted to go back and take a look at the RFCs, I highly recommend taking a look at RFC 2328, which was back in 1998, one of the original RFCs for OSPF version 2. And in here it talks about the authentication methods. However, RFC 5709 is the RFC that updates, or I should say enhances RFC 2328, and they say right here, updates 2328, because this is the RFC that details, very short RFC, 14 pages, but it talks about the update that it's making with the secure hash algorithm using the hashed message authentication code, right? And this is a NIST enhancement, and you can see where we're going to be supporting SHA-1, 224, 256, 384, and 512. So again, you should be very familiar at the CCIE level with RFC 2328, and then RFC 5709, which talks again about the enhancements that were made. In the Cisco implementation, you're going to want to be at 15.4.1T. And I'm actually going to show you that with, and this is an actual physical Cisco 1841 router that is running, that is running 15.33 code. And I'll show you that with the 15.33 code, it's not even there. The options that we're going to be configuring aren't even there to be configured. Okay, so let's go ahead and jump in here, and we're going to go back to our setup. For those of you that didn't see the first set of videos, this is basically what we have: router 1, router 6, router 4. So router 1 was using sort of the original OSPF configuration, where we did the declaration of the authentication statement under the global router config, and then we did the key setup under the interface. And routers 6 and 4 had both of those commands, the authentication piece as well as the key piece, done under the interface mode. Again, to demonstrate that you can mix and match within your environment. However, that's probably not advised, and that the process IDs on each of these 3 routers are different. So for router 1, the process ID for OSPF was 1, for 6 it was 6, and for 4 it was 4. Again, showing that that's a locally significant value. All right, so we're going to go ahead and start here on router 1. We left off on the interface, so let me jump out of the interface. So again, for cryptographic authentication, right, the keychain feature is an enhancement because, as you saw in the previous video, all we were able to do is we could declare a key or define a key. And if I do a do show run on Ethernet interface Ethernet 00, you can see that we've got the key defined there. However, when the previous key that was there was key 1, if I wanted to make a change to key 1, right, I had to go back into the interface, add in a new key, wait for that new key to be sent and received by all of the routers in that OSPF area where I wanted the authentication to take place, and then I had to go back in and remove the old key. And so the feature of a keychain and the functionality that the keychain provides is I can define several keys. And I can also set what they call the send lifetime and the receive lifetime. So I can actually configure my router to send one key, and then auto-magically at a given point in time that I define with my send lifetime, I can go ahead and deprecate that key automatically by the starting and sending of a new key, right? And we're going to see what that looks like here. Another quick point is in our debugs, we should continue to see that this is showing up as type 2. Because again, this is simply an enhancement to the cryptographic authentication. And so let's go ahead and get this set up. So the first step that we're going to do is we're going to define a keychain. So for those of you familiar with setting up keychains, this should be review. So we're going to go ahead and we're in global config, we'll say keychain, and I'm going to call this OSPF keys, right? So now it takes us down to this next level where we're going to go ahead and define the key, right? So it's a key with our key ID, and as you can see, it looks 2 billion different choices that we can make, so we'll keep it simple. We'll just do 10, 20, 30, 40. We'll set up some different keys. So I'll say key 10, and then here's where we define the key string. Right? So I'll just say key string and 0 meaning it's going to be unencrypted, and we'll say Cisco 123. Now, we're using 1541T. If I do the question mark here, you can see that we have an option for cryptographic algorithm. So we can actually choose the cryptographic algorithm that we would like to use. If I come over here to this 1841 router that I have, that's actually a physical router running 15.33 XB12, if I go into global config mode and I type in keychain OSPF keys, and then key ID is going to be, we'll just say 10, we'll keep it the same. And this router is not participating in the setup that you see below. This is just simply a physical standalone router right now that I'm using to demonstrate. And then we'll say key string, and the key string, whoops, sorry, missed my dash there, key string, and the key string name, or the key is just going to be, we'll say Cisco 123, and then if I do a question mark here, right, you can see the difference. So the 15.3 code doesn't implement the cryptographic algorithm selection. I've got a lot of other selections here, right? I've got my accept lifetime, my send lifetime, the key string, set a command to its defaults, but no cryptographic algorithm. So back over here, I've got the debug running, so let me kick that off again there. So you can see that I can now select the cryptographic algorithm that I want to use here. So we're going to go ahead and say cryptographic algorithm. If I do a question mark, just like RFC 5709 pointed out, it includes SHA-1, SHA-224, 256. Oh, I'm sorry, 224 is not there. So it's 1, 256, 384, and 512. And we could also use MD5 if we wanted to, but we know that we don't want to use that because it's considered legacy. We want to avoid that. So I'm going to say HMAC-SHA 512 because we're going to go for the maximum theoretical security that we can get. So we'll say cryptographic authentication or a cryptographic algorithm, HMAC-SHA 512. All right. So the last thing that we want to do is we want to set up the send lifetime. So I'm going to say do show clock because we're going to use the local time here. So by default it's going to be UTC, I believe. Yeah, it's going to be UTC by default. So we're going to send it with a local time. So I'm going to say send lifetime, and then my start time. I'm going to say 13 : and here's the format for the start time is 13 : 26 : 00. So we're going to give it a little over a minute to start. And if I do a question mark, whoops, 13, what do I want? 26 : 00, and then the start date. So we're going to say the 3rd day of November, and that's going to be 2014. And so now here's where we can say the time to stop. So we always want to have a little overlap in our keys. We can also set the key lifetime duration in seconds, or I can say infinite, that it never expires. So for this example, we want the key to expire, but I'm going to push it out about 5 minutes so that we can get some other keys configured. So I'm going to go ahead and say duration. Duration is going to be a value in seconds. And so 5 minutes would be 300 seconds. Okay, so we're going to be sending this key starting at 1326, and it's going to be have a duration of 300 seconds or 5 minutes. And then I went ahead and I just hit enter. Right? So now we've defined that key. So what we could also do, oops, and you know what? I think I overlooked, certainly did, overlook the local keyword, right? So the send lifetime, local 1326. So now if I do a do show clock and take a look at the local time, oops, so we're at 1426. I think I typoed the clock time. I certainly did. So let me pull this up, and we're going to say Control A, no send lifetime, and we're going to pull it back up, and we're going to set this to 14. We'll do 1427. I was looking at the debugs, so we're going to say 1427. All right. So if I do a do show, whoops. So if I do a do show, and we want to go ahead and take a look at the keys to see what we've got. So I can say do show key chain, and then I can give the name of the key chain, so OSPF keys, right? Let me turn debugging off here, do you all. It's getting a little crowded. All right, so we want to take a look at the output here. So as you can see, key 10, and there's the password, Cisco 123. The accept lifetime is always valid. By default, if you do not set the accept lifetime, it's going to be forever. And the send lifetime shows that we're going to be sending from 1427 for 300 seconds, and it says it's valid now. So I'm going to set up a second key here. And the reason we're going to set the second key up is because we want to make sure, and we'll say key 20, and we want to make sure that these keys transition smoothly. So we'll say key string for key 20, is going to be Juniper-123, right? And we're going to use the cryptographic algorithm. And again, I could pick a different cryptographic algorithm. It just needs to match up on the other side. Okay, so we're going to use HMAC-SHA, and we'll use 384 for the second key. And then I'm going to say the send lifetime. So if we did 5 minutes on the first key, I'm going to go ahead and set this to kick off here at, let's take a look at the clock real quick. So do show clock. Hopefully I can get to it. All right, so 14:28. This is cruising right along. So I'm going to set it for 14:31. So we've got the cryptographic algorithm set. So now we're going to do the send lifetime local. And again, we want to use local to use the local clock. And we're going to say the time would be 14, and I'll say 31:00, and that's going to be 3 November 2014. And how long do I want to send that one for? I'm going to extend it out. We're going to say 600. So I'm going to say duration 600. And so we're just going to double the time to 10 minutes. Okay, so the keys are set, right? However, we haven't applied these keys to any of the interfaces, and so here's where we're going to start to see some debug messages. So I'm going to go to interface Ethernet 00, and first we'll do a do show run interface Ethernet 00, and I'm going to say no IP OSPF authentication, and now we're going to apply the keychain. So very similar to how we did the MD5 authentication. I'm going to say IP OSPF, and it's going to be authentication. And as you can see here, now we're getting no valid authentication, right? So we can say keychain, and this is where we say OSPF-keys. So now I've defined the keychain. I've also defined the sequence those keys are going to be used. So again, if I were to do the show IP OSPF interface, Ethernet 00, the do in there. So you can see here, now it says sending security association, that's that SA, key 10, algorithm HMAC-SHA 12, keychain is OSPF keys. Now, we should see this change auto-magically once these keys expire. And so again, I'm going to go ahead and pull up the, maybe easier, there we go, do show keychain. So as you can see in my keychain now, I've got two keys, key 10 and key 20, and key 10 is going to go until it's still valid for 300 seconds, and then that key is going to age off, and at 14:31, this new key is going to come online. And so let's drop over here to R4, and as you can see, now we've got mismatched key authentication errors because we've got different keys with different key IDs, and we're also using different encryption algorithms. Okay? All right, so let's go ahead, and on R4, we're going to go ahead and say do you all. We're going to turn debugging off here, and we're going to bring debugging on back on router 1. So router 4 is going to be the first router to be set up with the keychain setup that we're currently using. All right, so again, the first thing we want to do is configure the keychain. So it's going to be keychain, OSPF keys, and we're going to say key 10, and we want those keys to match. And actually, we'll pick up with key 20. What's my clock? Show clock. I'm running out of time here. All right, so the other key 20 is already kicked in. So we'll do key 20, and we're going to say key string is simply Juniper-123. Let me confirm that that is what we're using over here. Yep, Juniper-123. All right, and the cryptographic algorithm for the Juniper-123 was the HMAC-SHA 384. And then my send lifetime is going to be, we're going to use the local clock. And so 14:32, I'll start at 14:34. So 14:34:6. on the 3rd of November 2014. And again, we'll say the duration, we're going to do this for 600 seconds. All right, so now defining the keys is good, but we need to remember now we need to go to the interface and make the application, make the change. So on router 4, do show IP interface brief. On router 4, we're looking at interface Ethernet 01. So Ethernet 01. So do show run int Ethernet 01. And as you can see here, we have the area command as well as the authentication and the IP OSPF message digest key setting. So under the interface here, we're going to pull off the authentication message digest, and we're also going to pull off the message digest key because we're no longer using MD5. Remember, now we're using our keychain, and the keychain already has the key set up for us. So we need to make sure we turn on the authentication. So we're going to say IP OSPF authentication keychain, and this is OSPF-keys. And so I'm going to go ahead and do a do debug IP OSPF adjacency here. And as you can see, we missed it a little. We'll see it on router 1, but now it's gone from loading to full. So if I come over here, you can see that now router 4 and router 1 have established an adjacency. So if I do a do show IP OSPF neighbor, you can see that router 1 only has an adjacency with router 4, and that's because they're using the same OSPF keychain with the same keys, right? So if I were to do a, excuse me, a little hoarse still. If I wanted to take a look at the keychains, if I were to do the do show key chain and then say, key chain and then OSPF-keys, do show key chain, oh, do show chain, sorry about that. So do show key chain and then CJIN OSPF keys, right? So there are my keys, and you can see that it shows the different keys that are being set or sent. The accept lifetime is, again, the default is it will always accept the keys. And so you can see here, send with youngest key, key 20, and that's the key that we're using here with Juniper 123. All right, so now I'm going to set up a key a little further out. So we're under the interface mode, so let's jump back into, excuse me, let's jump back into the keychain configuration. So I'm going to go back to global config, and we're simply going to say keychain OSPF keys. Let's add a key in with a unique number. And so this is going to be key 8675309, and then we're going to go back and configure router 6 with this as well. My key string will be 123 Cisco, and then we're going to say the cryptographic algorithm we're going to use is going to be HMAC-SHA, and we'll pick 256 for this one. And then my send lifetime, let's actually do a quick do show clock. We want a little overlap, so we know that we're going to be good for a few more minutes here, so I'm going to turn this on at 14, we'll say 14:45. So we'll say send lifetime. We're going to use the local clock at 14:45:00 on 3 November 2014. And the duration for that, we'll go ahead and set that to 1200 seconds, which is going to be 20 minutes. All right, so we've got that key set up. So if I rerun do show, where are we at here? We'll type it in, do show key, keychain, you can see that now we've got this third and final key, which is going to be sent starting at 14:45 local time, 3 November 2014 for 1200 seconds. So let's go add that key to this keychain here, and if I do a do show IP OSPF neighbors, you can see here where I still have my neighbor adjacency because the keys are still valid between routers 1 and 4. So let me add into the keychain here that 8675309 key. So we're going to say keychain, again, OSPF keys, and we're going to do key 8675309, and we're going to say the key string for this is going to be 123 Cisco, and then again we want to define the cryptographic algorithm. So invalid key ID message. So let's see what happens here. Cryptographic algorithm, HMAC-SHA, we're going to say 256. And then we're going to set the do show clock. Let's make sure do show clock. Let's make sure our time, right? So we set the other one for, I believe it was 1445. So we'll do that same thing here. So we're going to say send lifetime with the local clock of 144500 on 3 November 2014, and the duration is going to be 1200 seconds, which will be 20 minutes. All right, so that key has been set up as well. So now, if we come over to R6, you can see R6 is clearly saying that we've got a mismatched authentication key, ID 20. Now remember, let's turn debugging off here for a second. So remember, if I do a do show run interface Ethernet 00146, it was a sub interface, you can see that we're actually using key 20 right now, but it's message digest, right? And it's a different key, different password that's being used. So we're not actually going to be able to reestablish our adjacency until we configure a new key. So as you can see here, we're receiving a packet from router 6 and it says mismatched authentication key. However, we are still sending with the youngest key, which is key 20. Now keep in mind that the key, the number of the keys is the same, but it's a completely different cryptographic authentication that's being used. So we're using HMAC-SHA, and router 6 is still set up with the legacy MD5 method. So if we take a look at router 1 here, you can see router 1 is still sending key 20, and so let me do a do show clock, and you can see we're at 1440, so we've got about 4 minutes, a little over 4 minutes to go before these keys, and if you remember, if I do the do show keychain OSPF keys, at 1445 we should start sending that 8675309 key automatically along with key 20 until key 20 expires, and that was set for 10 minutes starting from 1431. So if I do a do show clock, so we are now at 1441, and so what we should see happen here is an automatic switching, or I shouldn't say switching of the keys, but a small overlap. And actually we're not going to have an overlap because I did it at 1445, but that's okay. What's going to end up happening is the 8675309 key should start sending here in about a little over 3 minutes. And so while the time is running down on that, we're going to come over here because we need to make some changes to this interface. So we're going to remove the OSPF authentication message digest, right, because we're no longer doing MD5, and we're going to take off the key. And as you can see, we've got a different process ID here than we do on the other two routers. Router 4 is process ID 4 for OSPF, and router 1 is process ID 1. All right, so we've removed all the authentication off of the interface for OSPF. And we're going to define a keychain here. But what we would like to see, and we're going to patiently wait here, so do show clock. All right, we've got just a little over 2.5 minutes to go before we set that up. So let's go ahead on 6. Let's define our keychain. All right, so let's exit out, and we're going to go ahead and say, excuse me, keychain is OSPF-keys. And if you were using a keychain for another protocol, you could actually use that same keychain right here when you configure it on an interface with the OSPF if you're using the HMAC-SHA. Or you can have a dedicated keychain to use with each protocol. My recommendation would be to dedicate a keychain for the routing protocol and not to use another one, because what you don't want to do is remove it, not remembering that, oh, that's right, my OSPF is also using that keychain. So let's go ahead and say keychain OSPF keys. The key ID is going to be 8675309. And let's see if it comes back and says that that's not valid. And so we're good there. The key string is going to be 123 Cisco. And the cryptographic algorithm is going to be the HMAC-SHA. We're going to use 256. And let's do a do show clock. And we are at 1443. So I'm going to set this guy's out to about 1447. So we're going to say send lifetime, local, and then the start time is going to be 1447:00, and we're going to be looking at a duration, or actually, I'm going to get the date here, 3 November 2014, with a duration of, and we'll say 1200 seconds. All right. So the keychain has now been defined. As you can see over here, we've got last key expiration, right? So at 1444, we're seeing messages telling us that the last key expired. So the last key has expired for interface Ethernet 00. Packets sent using last valid key. And so what that means is, it's going to continue to send using the last valid key that we had, and in this case, that was key 20. So let's go ahead and do a do show keychain, and you can see that now we're receiving invalid key ID 8675309, and keychain OSPF keys is invalid, right? So no valid authentication key is available, so it's going to continue to use that last key, right? Because if we take a look here and say, if we're in the keychain and we do the do show keychain OSPF, if we were to try to create a different key, right, with a different key ID, you can see that we can use a very large number, but it's saying that it's invalid. And why is that? Let's come over and take a look here at router 4. Same thing. Invalid key ID 8675309, and keychain OSPF keys is invalid. All right, so there's no valid authentication key for the interface Ethernet 01, and it's going to continue to send the packets with key ID 20. So what's happening here is it's not just going to stop doing the authentication, it's simply going to use the last valid key. And in our case, that was key 20. So over here, same thing. If I were to apply this key to interface, and we'd go to interface Ethernet 0/0.146, and if I were to say IP OSPF, and authentication, the keychain, authentication keychain OSPF-keys, you should see that there's no valid authentication key available, right? It's telling us that that is not a valid key. All right, so let's go ahead and let's create one last key to bring the adjacency up across the board, and we're going to exit out here one step. And we're going to go ahead and create, let's say, keychain, and we're going to go back into OSPF keys. So we're back into the OSPF keys. If we take a look at the keys we have in here, we've got those 3 keys, one of which is invalid. So we're going to say key 50. So we'll use key 50 as our key. We're going to say that the key string is 123 Juniper. We're going to say that the cryptographic algorithm is going to be HMAC-SHA, and we'll just use 1. And then we're going to do our send lifetime. So do show clock. You can see it's 1447. We're going to start this at 1450. So the send lifetime for the key is going to be, we want to use local time, and we're going to say 1450:00:3 November 2014 duration, and we'll set it for 40 minutes because this is the last key that we're going to set. All right, so that key has been set. We've got our debug on. Now let's jump over to router 4 and configure that as well. So we're going to exit out here. All right, so we are in the OSPF keychain configuration. So we're going to say key 50. We're going to set the key string to 123 Juniper. And before I do that, let me confirm. I need to make sure here. Where do we set that? Make sure it's 123 Juniper. And now you can see it's already sending with that youngest key, right? Key 50. And I need to make sure we did 123 Juniper. Yep, okay, we did. Good. So it's 123 Juniper. So I set it for key string 123 Juniper, cryptographic algorithm, HMAC-SHA 1 is what we're going to use. And do show clock. Let's make sure that it's 1449. And so we're going to go ahead and say, and there you go, it's sending with youngest key 50. And we're going to do the, and so just to pause here real quickly, so you'll notice I don't have to go back into the interface, right? Whereas before, when we were doing the MD5, I would have to go into the interface and then define the new key. Here, under the interface, remember that what we're showing, so if I do show run interface Ethernet 0/1, I misspelled Ethernet? I sure did. Ethernet 0/1. Remember, we're just defining the key chain that we're using here. So instead of having to go into the interface to make the change, we just simply go to the key chain and make the change. And so let me turn debugging off here so I can scroll back, so do you all. So if I scroll back a little bit, you can see that as soon as I defined the password and the cryptographic algorithm, it started to send key 50, right, with the key ID 50, but more importantly, as soon as the algorithm was defined and the password had been defined, you can see that two-way communication starts to come up, and now I'm sending with key 50, right? Because on the interface, it's simply referencing this key chain. So I make the change in one location, and if I had, let's say, maybe 50 interfaces that were using this specific key chain, they would all auto-magically update. All right, so we left off with cryptographic algorithm HMAC-SHA 1, and we wanted to do the send lifetime. We're going to use the local, and we're going to say 1450, and it's actually past 1450 right now, I believe, so let's do a do show clock. So 1451. So I'll say cryptographic algorithm HMAC-SHA, the send lifetime, we're going to use the local clock, and I'm going to say 1452:00 on 3 November 2014 in a duration of 2400 seconds. All right, so I hit enter, and now notice what happened. It says the keys, well, the keys for 8675309 are invalid. We have no a valid authentication key right now. You can see here it expired because it was only 1451. It's not 1452 yet. So if I do show clock real quick, you can see we've got 10 seconds before we should see the new key, right? Because as soon as I put the send time in there, if you don't put the send time in there, it's going to send it immediately. As soon as I put the send time in there, it stopped sending it because it wasn't 1452 yet. So in 10 seconds, do show clock. You can see now that it's 1452. So if I step over here to router 1 is sending with his key 50, router 4. If I do show IP OSPF adjacency, I'm sorry, neighbor, NEIGHBOR, you can see that now that key is valid, and I turn debugging off here. If I do a do debug IP OSPF adjacency, you can see we have debugging on, so we should see the message that there it is, that we're now sending with the youngest key. All right, so router 6 is still a problem. So let's get over here and let's take care of router 6. So we're going to exit out here. We're going to say keychain. We're going to go into our OSPF keys, keychain. We're going to say key 50. We're going to set the key string for that to 123 Juniper. The cryptographic algorithm we're going to use is going to be HMAC-SHA 1. And then I'm going to go ahead and say the send, let's do a do show clock. And, realistically, and so there you go, right? So as soon as I set the cryptographic algorithm, right, and define the password, it immediately starts sending the key. So the reason I'm using the send lifetime is because maybe I want to rotate keys every 90 days, right? It might be a security precaution within your organization that, every 60, 90, 120 days, maybe even every 30 days, you've got to change your keys to make sure that your cryptographic authentication is being routinely updated to protect yourself from being hacked. So again, by default, if you don't define the send lifetime, it's going to start sending immediately, and it's going to send infinitely. So the information that it needs to establish the adjacency has now been provided, and this is before I set the send lifetime. But we'll go ahead and we'll say send lifetime local. We're going to use our local clock. If you don't, it defaults to UTC time. And I will say 14:54:00, and we're going to start that on 3 November 2014. Whoops, 2014. And our duration, and there's some different choices you can choose from. You can use duration. You can actually tell it when to stop, or you can say infinite, right? So we'll just say duration in 2,400 seconds. All right. So if I do the do show clock right now, you can see it's 14:55. If I do a do show IP OSPF neighbors, you can see that my neighbor relationships are there, right? Over here on router 4, it's now just sending the youngest key, which is key ID 50. We saw it transition from a valid key to an invalid key, and then we set it up with key 50. And so now if I do a do show IP OSPF neighbor here, router 1 sees 4 and 6, has an adjacency established, and router 1 sees 4 and 6, router 4 sees the OSPF neighbor, sees 1 and 6, and we already saw that 6 now sees 1 and 4. Okay, again, the command to take a look at the keys that you have set up in your key chain is going to be show IP, or I apologize, show key chain. So if I want to do a do show key chain OSPF keys, I can see what keys I've got, or which keys I have. I can see which keys are valid, which keys are not valid. And you'll notice that key 10, and this is another nice benefit of the keychain, key 10 that we initially used, that key is now gone because its send lifetime has expired and the adjacency was established with a new key, which is key 50. And so that key has disappeared. So if I were to run that same command of do show key chain OSPF-keys, you can see here that the key 10 still shows over here on router 1, and we had it in for 500 seconds. However, on router 4, actually, I'm trying to remember if we set keychain 10. Actually, we did not set keychain 10 there on router 4, which is why it's not there. All right. So the keys will be there. You can go in and do your key cleanup as you would normally. And that is, so this is kind of this wraps up our video tutorial on using the cryptographic authentication with OSPF version 2, leveraging keychains, as well as leveraging the HMAC-SHA algorithms that have been provided by NIST to increase the security of your authentication within your OSPF domain. All right, and then again, one quick go back is you want to make sure that if the key is no longer being used, you can actually go in and remove that key. And so on router 1, where we had key 10, right, if I exit out, I could say no key 10, And now if I run the do show keychain, you can see that that key is gone. So once you know you're using a more recent key and you have a legacy key that you no longer want to have there, you can go ahead and remove that key just like you would with the legacy MD5 authentication. All right. Well, hopefully you've got a little bit out of this video tutorial and you know a little bit more about keychains with OSPFv2 and the RFCs that you would need to get some more information. And that's it. That's all I've got. All right. Thanks for watching and have a great day.